This presentation is on the Asynchronous Module Definition specification, or AMD for short. In this presentation, I will begin by explaining what AMD is and how it can be utilized to craft better, quicker loading JavaScript-based applications. After showing you the benefits of the AMD specification, I will walk you through an implementation of the specification, RequireJS, so that you will have a reference to a working example of this specification. My name is Tyler Kirk, and I'm a student in my last year at San Diego State University. This presentation is being completed as a requirement for my CS 490 senior seminar class. As I said earlier, AMD stands for Asynchronous Module Definition. If we begin to take a closer look at each word in the AMD acronym, we can begin to see why AMD loading can be seen as a preferred way of loading JavaScript files. Beginning with the first word, asynchronous, defined as two or more objects or events not existing or happening at the same time. This definition may be a bit confusing at first, so to clarify, there is an example on the following slide. In this example diagram, we can see that a project needs 3 modules to load. We can see where the asynchronous portion of the AMD specification behavior is beneficial when looking at where the 3 modules finish loading. In the top route, we can see synchronous behavior in which one module needs to finish loading before the other can begin. In the bottom loop, we can see that thanks to the asynchronous behavior in which more than one module can be processed at one time, the bottom loop finishes in almost half the time. This time equates to faster page loading, one of the major benefits of the AMD specification. Now continuing on to the second word in the acronym, module. Module is defined as each part of a set of standardized parts or independent units that can be used to construct a more complex structure. Here we can see the non-AMD modular way of loading JavaScript files. It appears attempts have been made to modularize the JavaScript code, which is an okay solution for the time being. But when the project begins to grow towards hundreds of JavaScript files, another solution is necessary to better keep everything organized for developers. This is where the modular portion of AMD comes into play. Rather than having to remember which files are dependent upon others, we can specify with one header for each JavaScript file which other modules a given file needs to run smoothly. The above lines of code can be simplified into one AMD defined header. We now just have one script tag which loads the 4 files with ease in an asynchronous manner. This is all thanks to the define function. Breaking down the body of the define function, the first parameter is an array of strings which correspond to the files that you would like to load. The second parameter is a special function referred to as the factory function, which will return a value that will be used as a reference for that defined module. This factory function will be ran only once all files that the first parameter of the define function specifies are finished loading. If following proper AMD loading, each one of the specified dependencies should have similar defined headers specifying each one of their dependencies. Another thing to take note of is the parameters being passed into the factory function. The 4 values seen here contain the return values from the specified dependencies: taco, cat, race, and car. We now have references to the other modules. The order of the parameters will correspond to the order of specified dependencies in the array. I would like to reiterate one more time that the console.log message will only be ran once the specified 4 files are finished loading. This is all thanks to the asynchronous module loading defined by AMD. Modularized programming is good programming. A given module should only contain the logic it needs to use to get the original purpose of the module completed. If Module 2 were to be no longer necessary, and no dependencies specified by either Module 1 or 3 on Module 2, simply removing any references to the Module 2 in the defined header in the original loader should be enough to remove Module 2 and ultimately clean up the code. The AMD specification, forcing programmers to code with modular behavior in mind, results in better written and organized code. And finally, we come to the definition portion of the AMD acronym. Though I'm sure you all know what the definition of definition means, the benefit for the definition portion of the AMD acronym can be seen in the standard it creates. Two of the most popular JavaScript libraries that have implemented the AMD specification are RequireJS and the Dojo toolkit. For the purposes of this presentation and an example of how to use an AMD supported library, I will walk you through how to use RequireJS. Both RequireJS and the Dojo toolkit follow the AMD specification. I've chosen to show you how to use the RequireJS library as I am more familiar with its capabilities. RequireJS is a file and module loader which has implemented the AMD specification. RequireJS is optimized for in-browser use, but with minor configuration changes can be used for other environments such as Node.js. If implementing RequireJS properly, there is only a single entry point into loading all JavaScript files specified with the data main tag. With one line of code, an entire project can begin to load. RequireJS supports some custom configuration settings in the requirejs.config location. The data main tag is used when loading the RequireJS source code. I would like to mention that the RequireJS source code can be downloaded at the link on the bottom of the slide. The downloaded file should be pointed to by the source tag to the location in your JavaScript project where you have placed the required source code. The data main tag is used by RequireJS as the one-stop shop to load all of your project's JavaScript. Inside of data main is a good place to put the next subject of discussion, RequireJS's configuration settings. The config section is normally placed at the top of the file specified by the data main tag. This is done so that Require is configured how you would like it to be before loading up your project. More configuration options can be found at the link provided. I will walk you through three of them: base URL, wait seconds, and paths. The base URL parameter can be used to change the RequireJS root directory for loading dependencies. If no base URL is explicitly set in the configuration, the default value will be the location of the HTML page. The base URL configuration comes in handy if a program, scripts, folder were to change locations relative to the HTML file. Rather than having to change every dependency reference, you only have to change the base URL. The wait seconds parameter specifies the number of seconds to wait before giving up on loading a script. If no wait seconds is specified, the default is 7 seconds. Setting it to 0 disables the timeout completely. The wait seconds parameter should be set to a value that will ensure enough time has passed before RequireJS complains that it was unable to find a certain file. And finally, the paths parameter. The paths parameter is used to modularize the references to a given file or package. This helps to shorten the module references when used in the defined headers. Similar to how the base URL parameter makes it easy to manage if a folder directory changes, a similar benefit can be seen if folder 2 were to change locations to simple scripts AB folder 2 rather than scripts A, B, C, D, E, F, G folder 2. I hope that this presentation was able to help you better understand the asynchronous module definition specification and the advantages of utilizing an implementation library like RequireJS to better manage your JavaScript projects. If you have any further questions, feel free to send me an email at motoprogrammer@gmail.com. There is much more to the RequireJS library than what I have went over today, so please refer to the RequireJS website to get a better understanding of what the open source library has to offer. Thank you.